Without further ado, I'm going to go into the introduction. It's going to be a very lovely structure. We've got three brilliant speakers. Each one's going to do a presentation of about 15 minutes. We will then assemble onto these stools, try not to fall off them, and do a Q&A and discussion about what you've heard for 15 minutes, and then we will go back to the food and drink. So prepare for a lovely hour of your life. So this is the first event in Fujitsu's Nova series, which is a thought leadership program that's going to shine a light, or aims to shine a light, on new but tangible aspects of innovation. We want the ones specifically that are influencing our current and future economy. And I say that because, of course, today we had the UK government science and technology strategy unveiled earlier, and it had three key points that I know will be of interest. One was tackling malign influences. Take that as broadly as you would like. The second was supporting UK tech at home and abroad. And the third was the goal of being a tech superpower by 2030, which is fairly ambitious. I think that gives us 7.5 years to get going. So take notes from what we're going to say tonight, and then you can go and action it. We're going to be looking at three types of technologies and how we might apply them, specifically focusing on artificial intelligence, which obviously is a massive topic in its own right. So we'll see how far we get with that. Quantum computing and digital twins. Again, always with the focus on how this is going to enable growth. So without further ado, I'm going to introduce our first speaker, which is Dr. Keith Deere, the first of three doctors. None of us are medically trained to be on this stage. So, Dr. Deere.
The UK already is a science superpower, right? We've been number one for citation weightings in the G7 every year, going back to 2004. There's no doubt that our research leads the world. Where we have struggled is in the commercialization of that research, and where, if we take an even more clear-eyed view, one of the areas that we need to look at is some of the biases in those rankings. So Paul Nightingale and my former colleague in number 10, James Phillips, published something last week looking at, well, are we really world leading in science? And showed that the answer is probably yes, even in some of the cutting edge fields, but heavily biased by things like the presence of DeepMind and the publications of some very large organizations. So I don't think that ambition to get where we need to get by 2030 is unrealistic, but it requires, as Minister George Freeman has said, it requires us to be not just a science superpower, but an innovation nation. And one of the reasons why that's so essential is because it will supercharge our economic growth. It's a really exciting time to be in the tech industry. We're living through an area which is not so much paradigm shifting, as it says on the slide, as living through multiple phase shifts, a dizzying array of different phase shifts. And you'll see that theme run through what we're going to say today. In the Centre for Cognitive and Advanced Technologies within Fujitsu, we have the mission to revolutionize decision making. Why is that? Well, Ash Fontana, the venture capitalist, one of the world's leading venture capitalists, wrote in his book, The AI First Company, that where the companies that succeeded in the 20th century were those that leveraged land, labour and capital most effectively, those that succeed in the 21st will be those that leverage information. Leveraging information is fundamentally a human cognitive function. It's getting insight and foresight from data at unprecedented levels, at unprecedented speed and with unprecedented accuracy. I think technology is already revolutionizing decision making, and I hope you'll see why that is and how that might help to drive growth as we go through some of the more detailed elements of the presentation. The UK also faces some intractable challenges, and good strategy looks those challenges in the face, so I won't flinch from starting with a description. The UK's economic growth was ranked by the Organisation for Economic Cooperation and Development the second worst in the G20 over the last year, and the forecast for the next financial year is that UK economic growth will go backwards. We will contract, and we'll be the only country, apart from Russia, that is true of. Why is that the case? Well, I would start by saying that I'm always wary of monocausal explanations for any complex phenomenon. But nevertheless, in this instance, I might permit myself one, which is to lean on the economist Paul Krugman's aphorism, which is that while productivity isn't everything, in the long run, it is almost everything. One of the reasons for the UK's challenges is the productivity gap that has opened up, particularly since 2007. So since the Second World War, we've had each generation more prosperous than the last. We've been able to get more productivity out per worker, per hour for every generation, and the consequence of that has been consistently increasing wealth for families and for individuals and for societies. And that trend line since 2007 has begun to go in a different direction. You can see on the chart on, I think as you look at it, the right-hand side possibly, but where labour productivity has departed from that trend line such that it's now 22% below, I believe it's 22% below where it would have been if we continued on where it was previously. And that comes from quite a baseline, low baseline in the UK of productivity, so low growth from a low baseline. We're also 13% below the G7 average. You might think, well, these are all abstract numbers, Keith. Why should I care? Well, the think tank, the Resolution Foundation, in a statistic that was popularised this week through a Panorama programme, described how what that means in practice is a significant gap in household income displayed on the chart. And for the average worker, we are all £11,000 worse off as an average worker in the UK as a result of that productivity gap. Why does that matter? Well, not only does it mean it matters for all of you because you've got 11k less in your pocket than you would have done if we'd continued on trend, it also matters because that kind of money would also help to drive growth in GDP, and that growth in GDP would be reinvested in schools, in health, in public services, in infrastructure, in research and development. And in doing so, what you then get is a kind of flywheel where greater productivity begets greater productivity and greater economic growth begets greater economic growth. So we have to tackle the productivity challenge if we're to tackle the UK's growth challenge. How do you tackle a productivity challenge? Well, any business leader will tell you that there are four principal ways. On the one hand, you can decrease the costs, and that's true for companies and it's true for countries. So that might be things like the cost of energy, it might be things like the cost of materials, the cost of natural resources. You could decrease the costs, and now you can invest more elsewhere, and you can increase the productivity of your organisation. You can add labour. So at the UK level, you can increase like the number of people in the population. Now you can manufacture more, and historically now you can provide more services. You can add capital, you can invest more in your infrastructure, in your people, and through adding that capital, you can help to drive increased productivity. Or, and crucially for today, you can increase the number of ideas and the application of those ideas in the way in which your company or your country or you as an individual go about your business on a day-to-day basis. Costs, labour and capital are all things that are tightly constrained. Costs, it takes a very long time to change the price of energy. Labour is driven by long-term demographic trends about which I think governments and companies can do little. Capital is constrained by the bond market and the financial markets. You can only invest as much as they are willing. And we could have a big macroeconomic debate about how much governments can borrow, but nevertheless, broadly, there are some constraints on what you can do. Ideas, there are no constraints beyond our imagination. Bayes' innovation report a couple of years ago claimed that 51% of productivity growth is from innovation. So if that is true, that's the area where we need to focus to adopt that growth gap that we highlighted on the previous slide. Really important thing I want to draw out at this point is that is about technology, and I'm going to talk about technology, and so is Jason, and so is Alana. But it's also about the way in which we apply that technology. So that 51% of productivity growth was as much from the redesign of business models, from the redesign of organizations, from the changing of hierarchies, from true digital transformation, as opposed to mere modernization and the application of technologies to processes and the way you did things before. I think you need that in companies. I think if you're not reimagining your company around these technologies, then you are probably failing. I think we need it at the level of societies and we need it at the level of states. Japan talks about achieving the complete digital transformation of society by 2025. The UK science superpower, I think, shows that we get the same urgency. And I think the machinery of government reforms that you saw Rishi Sunak announce a few weeks ago when we created the Department for Science, Innovation and Technology were another recognition of the need to do real things. There was almost no political capital gained from that decision, and yet he made it anyway. And I think it shows the seriousness with which we're taking these, but we could, of course, do more. When we launched the integrated review, it's recently refreshed and came up with the science superpower agenda, our argument within the team was that automation, robotics and AI were revolutionising our path to prosperity and national power. They enabled companies and countries to scale to produce wealth independently of the number of people in the company or the country, possibly for the first time. And that growth, I think you can now see backed up in statistics like those on the chart from the Bank of America that show the number of workers needed at S&P 500 companies to generate $100 million in revenue over time, with that precipitate drop from the 1980s to recently, where it's far fewer people needed to generate the same amount of revenue. At the same time, and more recently, we've seen the cost to train AI systems dropping precipitately, and that is now embedded in the changes you see on the graph in producing more with less. So one of the ways we increase productivity, one of the ways we get more out of workers per hour, one of the ways we increase our GDP and our growth is through the application of these technologies. Interestingly, I think in 2010 there was no AI anywhere. Since about 2016, it's increasingly been everywhere. It's in your Maps apps, it's in trading on the stock exchange, it's there in your personally curated, tailored social media feed, it's there when you search on Google, it's in almost everything, touching every element of everyday life, and yet we haven't really felt it. The Alan Turing Institute said last week that the release of ChatGPT changes that. For the first time, people can feel how AI is going to change the world, change their companies, change their lives. I think really interesting to demonstrate that and perhaps to drive the point home is Professor Ethan Mollick at the Wharton Business School, who I still think, and I know this is on camera, is about the best Twitter follow I've ever found. You're welcome, Ethan. Ethan Mollick has said, in taking recent survey data, that it seems like ChatGPT, for those that are applying it, is driving an increase in productivity of, on average, between 30 and 80%, depending on the industry that you're in. 30 to 80% increases in productivity. Compare that to the gap that we have in growth of 22% and 13%, 22% from the baseline, the gap from the OECD of 13%, and you can begin to see how these technologies can help us address fundamental challenges. To sort of illustrate a little bit further of where we've come from to talk about where we're going, what you see on the slide is Professor Hans Moravec's Landscape of Human Competence. Hans came up with that in a paper in 1997 titled When Will Computer Hardware Exceed the Human Brain? And he described the rising tide of AI capabilities, so the sea represents AI, and the land were those things that we then considered to be uniquely human capabilities. In 2018, MIT physicist Max Tegmark took that description and turned it into the graphic that more or less you see on the slide. Obviously, for copyright purposes, we've got our own version, but nevertheless. And what you see there is things that we once thought were uniquely human capabilities already submerged. And what we've done is redefine what we mean by human intelligence, increasingly to mean those things that machine can't quite do yet. So we used to say it was chess. When it can beat us at chess, it's truly intelligent. When it can beat us at Go, when it can do, well, it's done all those things. The things in blue are interesting because where I've put those squares around it, those are things on this graphic that I have had to concede that machines are doing at least close to the level of humans since I started using this graphic in about 2019. So you can see that rising tide is very rapid to the point where probably I need to redraw the graph, but then I can't make this point. So I think we're seeing rapid changes and they're only going to increase. One of the things Tegmark said in 2018 is the real change, the most profound change, comes when machines begin improving machines. In 2021, a paper published in Nature talks about how AI and machine learning were now being used to redesign semiconductor base plates, the floor plans of semiconductors, on which those AI ML models will later run. So that is machines improving machines in the hardware. In December 2022, in a paper from Anthropic AI, a spin-out from OpenAI that built ChatGPT, they described how, through the application of reinforcement learning through AI feedback, they have now moved further away from reliance on human supervision and closer to the possibility of a self-supervised approach to alignment. So that is now AI and machine learning, or machine learning in this case, being used to make sure that machine learning doesn't do things we don't want it to do. We are approaching Tegmark's position where machines are improving machines and we're approaching it rapidly. In some ways, we're approaching it predictably. The three graphs that you see at the top of the slide describe how increases in computational power, increases in data set size, and increasing numbers of parameters in models consistently improves performance. And that allows those working in the field to say, well, if we can just apply a bit more power, just a bit more data, this is the kind of increased performance we're going to get. On the other hand, what you see in the 8 graphs below it are, for the first time, emergence. So emergences are those things that you couldn't predict from the parts or in advance, but when you get enough complexity, some new property that wasn't previously predictable emerges. And what you see there is large language models like ChatGPT, like GPT-4, getting to a stage now where when you apply more compute, they do things that aren't linear, are completely non-linear, that we did not predict. So you're teaching a language model to learn language on the internet, and suddenly it can do arithmetic. Suddenly it can translate between languages. Suddenly it can translate from human language to code, from code back to human, and from one form of code to another form of code. They weren't predictable. They are emergent properties. They are phase shifts, and they are dizzying. And whilst phase shifts has a real meaningful definition and description in AI and machine learning, I think it's equally applicable to apply analogously in a range of technologies, and that's what we're talking about today. I'm not going to talk about all these technologies. Collective intelligence and cyber-physical infrastructure, Jason will touch on and do far more justice to than I. Ilana will talk about the way in which quantum computing is enabling phase shifts. What I will say is that I think where we're heading is a world where decisions are completely revolutionized, where we have to think about humans as nodes in a wider intelligence network, where we need neuromorphic architectures that match those massive increases in performance with increases in the size, weight, and power that match human capabilities in hardware and in the software that runs on them. A world in which the boundaries between the virtual and physical are blurred through AR and VR, mixed reality, through cyber-physical infrastructure, and a world where explainable AI is absolutely crucial if we're to use these technologies in areas where decisions need to be audited. So they're the technologies, they're the ones that Fujitsu is working on actively in different ways through the centre. I think the other thing to say is, of course, there'll be phase shifts in other technologies like fusion, for example, like in space that sit outside the remit of today. It's a dizzying period to live through, and it's an exciting one. But we need to move from ideas to growth. So how do we do that? I think the first thing that is really positive are things like the recent Tony Blair and William Hague paper calling for cross-party consensus so that we understand how profound these changes are, how they help us to address intractable challenges that drive economic growth, that allow us to address all the other challenges that are political priorities for the different parties. I think we need to match the profundity of the vision that we're seeing and the machinery of government changes that we've seen with real action. So if it's true that we've got a flywheel of productivity begetting productivity and growth begetting growth, we also have a flywheel of investment in R&D, where investment in R&D from government drives private sector investment, which in turn gives the government more money to invest in R&D, which in turn can drive. So we need to begin to see that as the opportunity and not the risk it is, and change the public narrative so they understand that more investment in R&D isn't, in the longer term, less investment in the NHS or less investment for railway workers. I think we need to begin to challenge the narrative across all parties that this growth is going to be principally driven by small and medium enterprises. SMEs alone have an absolutely vital role to play in the economy and in driving economic growth, and we'll explore that later in the series. Nevertheless, the figures from 2020 showed that UK business expenditure on R&D, only 11% of that R&D was driven by SMEs. Most of it was driven by large corporates. The recent revision in the figures changed that number quite significantly, and we can come back to that in questions. But if you look at Nightingale and Code's paper back from 2016, they show that increases in productivity from R&D investment are principally driven by investment in large corporates. Why? Because large corporates have the scale with the customers to apply it broadly in multiple domains all at once. I think the next thing to say is we need realism. So we need to help organisations overcome the innovator's dilemma. That is helping customers to de-risk investment in new technologies, helping suppliers like us de-risk investment in new technologies where we can be nervous of not quite getting it right, helping SMEs to come into that ecosystem, and the government putting in money to do it. That's the model for the Fraunhofer Institute in Germany, where they have money that they invest that says, well, we'll put in X amount, the customer puts in X amount, the supplier puts in X amount, and now we all innovate and co-create together. The UK has adopted that model from the Catapult, but I think it's still a bit half-hearted. Investment in the Fraunhofers is 2.51 billion a year. Investment in the Catapults is 1.6 billion over 5 years. So we do need to move from the agenda and the ambition and the increasing investment in some areas to really serious investment in really big areas. I think we need digital transformation, the reimagination of society, countries, companies, not just the application of technology. That means breaking down some really hard barriers. I think we face intractable challenges for a long time that we can now begin to tackle through the application of these technologies in new ways. And that ultimately requires investment. It requires a hard-nosed and clear-eyed view of the future and what it holds. And it also requires us to understand that phase shifts are by no means always positive. And we need to think about the kind of disruption this is going to drive in economies, societies, and governments to make sure we address those challenges, even as we seize massive opportunity. Thank you.
It's a pleasure to be here to talk about this today. I'm going to try and strike a balance between calming things down a little bit when I talk about digital twins and also lighting a little bit of a fire in the same way that Keith has just done, because what we can see coming here is what he's just referred to as a phase shift. Now, we've been building models of our environment to enable us to make decisions about it, to plan and to execute for as long as we've been social animals. We used to call them maps, we've called them models, we've called them war games on occasion, we've called them simulations. So if this is nothing new, what's changing? Well, we've got better and better at informing them. We've collected more and more data. We've built more accurate models of aeroplanes, more accurate models of buildings, more accurate models of the computer systems that we run. And those technologies that have enabled us to build those more and more accurate models have themselves been accelerating. And it's that combination of effects which is important. So when we look at the next trends in our cyber physical infrastructure, what we're concerned with isn't whether any one of those technical changes is coming to bear, but how they all combine together. If we look at just the number of sensors that we're seeing today, I mean, the number of Internet of Things devices, which are a key sensor feeding digital twins in this day and age, will have doubled between 2022 and 2025. The number of Earth-observing satellites over broadly the same period will have increased fivefold. Smartphone use has gone from 50% penetration to 85% penetration just in the last 5 years. So we are seeing an awful lot more access to data, which is giving us a more detailed picture of the environment around us in more and more dimensions than we ever conceived was possible. And none of those was driven specifically to produce a digital twin, but it's all there. When we look at storage, storage itself is something that will have doubled by the end of 2025 from now. So there's more and more data that's being put together and processed than ever before. And although that hasn't been done deliberately with the intention of producing a digital twin, it's relevant to what we're doing today. The smartphone you've got in your pocket outperforms the supercomputers at the turn of the century. And for those of us that are old enough to remember, telephones back then were something else entirely. For those of you that can't, they really weren't very good. So let's not even think about the power of supercomputers themselves today. And I tried to look at some of the figures around the number of pixels you could get in a virtual reality headset now, and I've kind of given up. Now that you can get retina displays inside headsets, it's sort of moot. We can now visualize, we can now interpret, we can now engage data in ways that we couldn't imagine 3, 4, 5 years ago. And these are all separate dimensions of progress. So when you put those together, if each of those is growing on an exponential curve, the combination of them is about to go through a step change, because those curves multiply together and you're going to get a complete phase shift from one thing to another. So these things feel really hard right now. They feel very, very difficult indeed to do, but all of the things that make them hard are changing technically. So the potential for a digital twin, for our model of reality, for the things that we want to assess, things that we want to play scenarios in, all of that's about to change very dramatically. We know what we're doing with this, but we don't know what we're going to be doing with it next year. Now, in the center, we've got a couple of priorities and particular areas in this that we're interested in that I want to prioritize. We've got a lot of experience in building digital twins of engineering systems, be those machines, be those engines, be those factories, and indeed of the environment around us, weather systems, mountains, roads, and so on. But the next step for us, which we think is going to be very, very fruitful for investment, is going to be when we're looking at social digital twins. Now, social digital twins focus on people. Rather than having people as an incidental part of the system, people are what the twin is about. And modeling people is hard. Every single individual is unique. You all behave very differently. You all behave in annoyingly unpredictable ways. And none of you can actually be captured accurately in a mathematical model, which I think is what really makes it very interesting. But at the same time, if you can model the way that people behave in their environment and with the technology that surrounds them, then you can do some pretty amazing things. You can start to model out your policies. You can start to model out your interventions with benefits payments or different tax regimes. If you have a model of an environment in which people are moving around, you can drop an infectious disease in and see how it spreads, and then you can take it back out and close down some parts of it and see what happens and see if it makes a difference. And you can start to simulate and test the things that you're doing and give evidence that the policies you're going to put in place will have the effect that you want. Now, all models are wrong. Some are useful. So we need to get clever at working out where there are limitations on using those models. But if we can start to do that, we can start to inform policy discussions and we can start to make a real difference. And we think some of these simulations that are possible and some of these models that are possible to put together with the technology and the data that's available today will not only be productive in their own right, but they enable you to test those policies that drive and lead to productivity more widely. So social digital twins are an area which are going to have enormous impact on the agenda that we've talked about here today. Those twins themselves, though, are challenging not only because they're a technical challenge to collect the data, they're challenging because of what they represent in terms of a decision-making function. They're going to contain information about people, and that information will be gathered directly because we've collected it as part of something that people know about. I'm going to go to the doctor, I know they've got my medical records. I go to a company to buy a mobile phone, I know that they've got my billing details. But a lot of information is now being put into databases that we don't expect is being collected. Our activities online going into the ad tech sector, and we're starting to see data being collected for one purpose and being transferred and handed over for another. Some of it with legitimate reasons which are being laid out in legislation and regulation, and some of it just through commercial practice. So there's going to be a natural concern about how people are represented in these data sets and what control you have over that representation. There's also going to be concern about who uses that information and makes decisions about you and how you engage with it. Now, where we think these will really make people smarter because of this collection of information is that the more information about more people that is in there, the better the model will be, but the greater the risks that come with it. But the more use of that model by more people, the safer its use will become. So we're quite committed to an open approach to developing digital twins here. We're looking at open standards, open architectures, open ways of working, open ethics, because if you can open this up and more people are engaged in being part of that twin, they can also be engaged in the policy discussions that are being made about it, and they can be engaged in the use of that information. This leads to properly informed digital democracy. And it's an attempt to, and it's important that we step away from just giving that information to a centralized decision maker who makes decisions in isolation in the dark. Make them in the light with everybody having visibility of the information that's in the twin, and you're really achieving something quite special, I think. And with that in mind, that's something that makes the collective smarter as well as the individuals smarter. So that's collective intelligence where everybody is better off as a result of it. It's not all going to be that easy, though. There are a number of challenges. There are some genuine tensions. I've talked about the tension there about how information is going to be gathered from people, and that is something which is a challenge in its own right. There's also that challenge around the way that privacy and security matches the agency that people have. Keith talked about this earlier on. How free are you to act if others have information about you? Our answer is that you should know that information and you should know how it's being used. But we've got to resolve that tension, and there are some potential changes coming because we're beginning to realize just how much of our digital lives has been captured. We need to converge on standards, but the technical standards are something that we're all fairly experienced in dealing with. When you start to put models together, particularly in the social domain, you're combining information from different data sets that were put together for different purposes that have a different understanding of the things that they're looking at. So you use the same word to talk about different things, and you use different words to talk about the same things, and we like to call that an ontology, which again is a word that you like to use to talk about things. What it really means is I can look at a data set from one domain, I can compare it to another, and they don't make sense, even once I formatted the data. So resolving some of those standards is equally important. And I think one of the key elements that we're going to have to get our heads around with this, and the illustration here is what I call ground rush. December last year, the vast majority of us hadn't heard about large language models. Now they're everywhere. We're worried about them. We're concerned about them. We're trying to decide what to do with them. That's a very, very quick pace of change. But that was a revolution that was being developed for a long time. And there were lots of people that saw it coming and understood that this was the potential. And we were still surprised by it. We think in digital twins there's a similar challenge here. There are a lot of technical changes happening very quickly that will give us the potential to make changes very, very fast. And somebody will do that, and they will be combined. Those data sets will be combined, those technologies will be integrated, and there will be a phase change in what's capable, and we'll still be taken by surprise when it happens. We don't have to be if we want to start to look a little bit ahead. So I'll just recap on that and say digital twins are the next evolution in digitally enabled decision support engines. We've been doing this for years. We've used maps, we've used models, we've used simulations. They're getting better. We think there's a phase change coming because of the combination of technologies. We think that's going to happen in the social as well as the engineering and the mechanical space. And we think it's going to make everybody as a society smarter and more able to engage in the process of the policy decisions that impact them. And we think we need to be ready for that change and start thinking about the implications of it now. I'll leave it there. Thank you very much.
So I was asked to cover some pieces on quantum and some of the challenges that quantum might represent in being associated with applying this type of technology at scale, as well as how can we mitigate some of these risks. So a bit of the background: I am CEO of a company called Oxford Quantum Circuits, and we build quantum computers. So what you can see here is one of our systems that's already deployed into a data center, actually just outside of Reading in Winnersh, which we're very excited by. There's more systems going all around the world. So we've got quantum computers deployed in multiple continents and available for our customers today. So the system that we've just deployed actually and announced last week is called Toshiko. It's named after Toshiko Yuasa, who is an incredible physicist. She was the first physicist recognized as a physicist in Japan. And this is the system we've got launching now in Tokyo in a data center as we speak. It's a 32-qubit system, and that will be made available to customers very, very soon. So we're super excited about this, but we built them. They exist. I think that's my first point. Lots of people don't realize that quantum computers exist. They exist today, and you can access them in lots of different ways. But they do represent a complete paradigm shift, a phase shift that we might be talking about in terms of technology advancement. There's huge potential across pretty much every single market vertical that is out there. Some of the stuff I'm really, really excited by are things in life sciences, for example. How can we start to apply quantum simulations and really understand the world around us, which is quantum mechanical at its very core? So every single atom, every single molecule that exists is quantum. And we currently don't fully understand how that works, which is providing huge limitations on how we develop drugs, how we develop new materials, why we can't understand the energy band gap for new batteries, why all of that's still really expensive and kept in the wet lab. Why can't we do that on today's supercomputers? Financial services with different sorts of risk optimization. How can I look at that? That's a huge example as well. Transport, things like that as well. So how can we think about networks, IoT? How can we leverage quantum to start to think about optimization at scale? Because every single time you add another quantum bit, another qubit, you're adding pretty much an exponential piece of power that you can start to leverage, which is incredibly, incredibly exciting. So it's going to touch pretty much every single market vertical that is out there today. And we're really excited about that. It's going to be incredibly lucrative. And if we start to think about some of the previous conversations that we were having in terms of other types of technologies and data, how can we start to think about what the next change past that point is going to be? So if you think about all of the challenges that have been represented already, quantum probably represents another exponential piece on top of that. So what are the challenges of quantum today, right? What are the things that we're finding people are really finding difficult? Well, first of all, there is the challenge of access. So it's a very disruptive technology, a super highly potentially disruptive technology. But we need to make sure that this disruption doesn't necessarily translate into business disruption. It needs to be able to seamlessly integrate into companies' existing infrastructure and not be kind of out on its own. We need to find ways to be able to integrate it really, really seamlessly in that way. So solving the problem, the challenge of access today is really, really important so that we can leverage that technology and apply that technology around the world. And some of the challenges, if you have it super separate, like in a research lab, you're going to need hybrid, right? So you're going to need to do classical computation coupled with, haha, it's a joke, quantum computation, and be able to do that seamlessly so you can have this super low latency access between quantum and classical. So you really need them in the same building and to be able to start solve some of those problems for access. Next up is learning. So it's really, really hard. I'm not going to lie, writing quantum algorithms is something I did 10 years ago. I couldn't write an algorithm today. But we need to be able to train our existing algorithms and be able, algorithm experts in quantum and help train the quantum workforce so that they know how to interact and learn how to use quantum applications and really help support that. The next piece is, of course, performance. So if you're already starting to interact with quantum to make sure your businesses are quantum ready, you need to be able to go back to your existing stakeholders and help them say, this is what it can do for us. But the performance of the systems today, there's still things that can be simulated. So the quantum computers, like that system that I've shown to Shiko, it could be simulated on today's supercomputers. So we're not yet quite at that point whereby you can solve problems that are intractable. But how can I still show my stakeholders that this is something we should be engaging with, this is something we should be doing, and make that business case? Because by 2027, we expect there'll be a pivot point where you've got systems that now have the underpinning performance of number of qubits, but not just number of qubits. Don't pay attention to the number of qubits, they really don't matter. You need really good qubits, you need overall systems of a really high quality, which is linked to a ton of underlying technical metrics, which yet does not have a benchmark. Huge problem, huge challenge for adopting this. How do we benchmark our systems so that you can accurately go, this is how a performance of this quantum system compares to a performance of a separate quantum system that isn't massively biased, of which pretty much all of them out there are today. So how do we start to think about solving some of these challenges? Well, first of all, we think about access. What we've launched at OQC is OQC Live, and this is all about solving that challenge of access. So to solve that, we help enable people with the ease of access, so you can access systems through both private access, through public cloud, through private cloud, as well as through direct interconnect now with our data center partnerships. Help make sure that you have increased security, so you know that your data, because that's one of the big challenges, is that customers didn't necessarily want to send their data to a little startup like us. So we make sure that our systems are end-to-end pen tested, we deploy them on things like AWS, we partner with these large companies, and we make sure that we meet the security requirements. And by putting our systems into data centers, you're effectively at the secure data endpoint for our customers. So it's like as if it's in the building. And by putting them into data centers, you also have super low latency. So it's next to their existing classical compute. And then you can do super low latency type control between classical quantum on site with direct interconnect. Beautiful problem solved. That's what we're doing with OQC Live. You can actually access our systems anytime between 10 and 1 through AWS. So if anybody's got an Amazon Bracket account, you can do that. Latency isn't great there, but actually ours is faster than all the others, especially in Europe. You can access through private cloud as well. So if you want to run POCs, you can run private cloud access, which means that you can just work with us directly. But the key thing we heard from people is that they need to make sure the data stays in the building. That was the challenge of access. And even through public cloud with AWS, even through private contracts, that was really the point where it's like, no, we need to put these systems into data centers today to have that security, to really make it sure that effectively the data stays in the building. So we're already partnered with Equinix, and we're also partnered with 6TeRa, which is fantastic. So that's one example of what we're doing to put quantum to production and to put the systems into data centers so you can have private access, public access, but also direct interconnect. And you can also have dark fiber connections. So it literally doesn't have to touch anything public cloud, anything else, super low latency. And then solving the problem of learning, we're doing this through OQC Labs. And I think Fujitsu also have similar programs. And this is all about supporting customers to experiment and learn from the outset. So we've got quantum algorithm engineers who can work with customers and work with people to help understand how they can transform their businesses to identify those specific use cases and help them with the onboarding to actually run quantum algorithms on actual systems today, because there are differences between actual systems versus simulators when you start to think about noise profiles and all of this type of stuff. All of this doesn't matter if you've not got a system that performs very well, so it all has to be underpinned by performance. And this is one of the biggest challenges of the systems today. Right, that photo that I showed you, that's like a room. It's probably like the size of this. So we're still thinking the 60s in terms of compute, where you've got physical rooms and you're coding almost as though you're coding individual gates. And you've got these amazing microwave setups and you're sending individual pulses. It's just phenomenal, but it's still where it was in classical compute equivalent of the 60s. And it's still got a way to go. But with increased system performance, we expect that pivot point for where it reaches business added value to change around 2027, when we'll be able to have, say, 50 to 100 qubits of high enough quality that you can really do super interesting problems. So to help underpin that performance, we need to have innovation, and innovation that can be very much inspired by some of the universities that we have here in the UK. We are absolutely fantastic at this. This is a picture of OQC's core IP that span out from the University of Oxford. That innovation was the foundation for everything that we do, and is a unique way of building a superconducting bit, and it's my job to make sure that we realise that commercialisation piece. We also have a strategy of building the core and partnering with the best, because the UK has a really, really fantastic ecosystem of quantum startups, as well as corporates, and leveraging that ecosystem and finding ways to collaborate together is going to be one of the things that helps underpin all of this type of innovation and success. So our goal is to make sure that we can bring quantum computing to customers' fingertips, underpinned by labs solving access, and also help enable them make breakthrough discoveries, underpinned by OQC labs itself. But we do have to recognise that there are risks in what I'm doing. You could be stood up here thinking, gosh, she's building quantum computers, she's going to be like Dr. Evil. But I'm very mindful of what we're doing, and I think we need to make sure that we are recognising that there are dangers in what we are building here. And I, as a CEO, am very, very privileged to be leading a company of 90 extraordinary engineers, but I do need to take deep responsibility, and I cannot be naive to the fact that just because it's well intended, it doesn't mean that the technology is going to be well applied. And if we think about quantum, we know that this could factorize algorithms, for example, or prime numbers, which would destroy RSA encryption, for example, which I think currently on classical compute is around 1 million years to decrypt. But if you wanted to be able to do that with a quantum computer, if you had around 20 million qubits, you could do that in 8 hours. Now, it's okay, we've got like 10, 15 years, but we should be thinking about these type of problems today. It's really, really important that we're doing that. So whose responsibility is it anyway? Well, first of all, it's definitely mine, and I definitely take deep responsibility for it. But the applications of quantum computing will impact society. So ultimately, this is a societal problem that impacts on industry. It requires government, it requires academia, it requires, what else did I write? Public interaction, and making sure that we're thinking about developing policies and regulations early. And this is a huge opportunity now. The field is nascent. There's very few times that we really get to take something from the start, learn from what's gone well and what's not gone well in previous type of technology phase shifts, so it doesn't come as a surprise, and make sure that we can really consider the way that we collaborate and think about ethics from first principles and build that in this new industrial revolution, in this new quantum revolution, and this new technological paradigm shift. So I'm focused on building a world-class company as well as world-class technology with ethics and tech for good at its core, which is why, if you look at the bottom right there, you can see a little OQC heart. And at OQC, we are a values-led company and we cultivate love in everything we do. So I'd like to encourage you all to think about how you would cultivate love in your businesses every day, and think about how we can drive business from a place of love rather than a place of fear. And you think I'm crazy, and I'll talk to you about it later. So that's all. Thank you very much. We're building a brighter future for all, enabled by quantum.
One of the first challenges that I would love to ask all of you, that we're talking about things that are very much at the cutting edge of technology. This is not just emerging technology. It can almost sort of feel like this is science fiction still. And yet, from your presentations today, we are being told that it's happening and it's real. And my question is, how are we going to capitalize on what these technologies have to offer, as well as be aware of the risks and put the love at the core, if we aren't taking the rest of the population with us. So if we aren't funding our schools and our teachers and our research agenda, and we're in a city right now where most of the academics are on strike because they're being defunded so much, that's a problem. And how are we going to make people feel that their data is safe and take it on more than just your word that you are not Dr. Evil, which I know you're not, but there's going to have to be an ethics framework and a transparency and an accountability framework that needs to be right at the heart of our democracy just down the river, but which we all have to have in this room, all of us, the collective room. So first questions, how do we get ready and train our workforce? How do we actually build in the protections and ethics and collective discussion around this technology so we can use it with confidence? And what do you think you need that you don't have now to get that going? Who wants to take it first?
I'll have a punt on something. I think there's you make a connection there, which I think Keith was alluding to earlier on, which is why I think I've got the answer, and I'm going to steal it from him. Which is that we can't afford to look at these technologies in isolation. There's no such thing as a pure and neutral technology. They are part of the social fabric. They're part of public discourse. They're being represented and discussed at the moment in the media, and we need to be cognizant of that. That's where people are learning about what these technologies are. That's where people are learning about the exciting things they bring. It's where they're learning, being told what to be scared of. And it's where that debate about how they're going to get utilized is going to pull through. So I think the first thing is, as technologists, we have to not be naive and think we're living in a glass cage, or somewhere pure and simple. It's not. It's a world in which these things matter. They matter from the get-go, and they're difficult, complicated, and they're dirty, and they're uncomfortable, and they'll make us make some decisions and choices about values very, very early on. And then I think if we engage that then leads us into being able to talk about how we educate those around us, how we work with schools, and how we work with policymakers to set the agenda for learning and training, how we decide to lead our companies, how we decide to work together as colleagues. All of these things put that at the center. But I think it starts with that there's nothing pure about technology. It's always part of something that's going on in the real world, and we can't afford, particularly the pace of change at the moment, we can't afford to duck that.
Thank you. Ilana, or
I mean, to echo what you've said there, I think value-led leadership is like end-to-end what we require. And that's value-led leadership within government, within businesses, like making sure that these are priorities and conversations that are had across the board, but more than just conversations, right? They then have to translate into actions and be completely weaved in to responsibilities of businesses. Like, how do we start to identify what those forcing functions are, and also make them accessible? I think we heard earlier about surprise of digital twins. We heard about surprise of technology advancement. But if you're deep in the technology, you know that this stuff is coming years and years and years out. So yeah, I think that's a really interesting point to make, is like, how do we start to engage the public in these conversations earlier, make them exciting, make them identify them as something that we should be talking about. And that also starts with our schools as well. I can't remember what some of the other questions were. Great.
Building public trust and accountability from
I think
Parliament
that ties too.
all the way out to customers. And it's not just people feeling safe to give you their data, for instance, with your company. It's also just in our wider society. A lot of this stuff is happening so fast, people are really scared.
Yeah. And rightly so.
We should name that, right? Like, part of building trust is empathy and saying, I'm scared by your slide that showed how few people are now needed to generate $1 million of revenue in an S&P 500 company. Because when I hear that, I hear job losses.
Yeah.
What I need to hear is, what's the job creation story?
100%. Well, hopefully I told both stories.
Great.
I think also what you should hear is massively widening wealth inequality.
Right.
If far fewer workers are producing far fewer value, they're likely being rewarded for that value creation. Now, on the one hand, that is probably fair in one view, and in another view, it's deeply inequitable for wider society. So you have to address both. I meant to bring that point out, so thank you for the gift back. I think one thing I would say to confront some of this a bit more head on, though, is when I talked about the flywheel effect, I think that's what we need to change in the political conversation. So right now, if you announced, I don't know, an extra like proportionate kind of US or EU investment in quantum computers in the UK would be many more billions than we're currently investing. And if you did that, you would instantly have a whole load of headlines in the newspapers that would say, well, hang on, why can't we pay railway workers more? We need more money for the NHS. We need more money for this. We need more money for that. And what would happen is short-term pressing, real political priorities that we should be worrying about would take precedence, and all of that money that was allocated for, I mean, without going into details, I've watched this happen. All of that money that would be allocated for R&D will suddenly be going on all those immediate pressing political priorities because they're more likely to get you re-elected. And what that means is, far from having the flywheel that sees productivity accelerating and therefore economic growth increasing and therefore more investment in turn in all of those things that we want to invest in, what you see over time is the meeting of immediate needs at the cost of long-term growth, and then you get that that curve that drops off. So like, if I was going to change a thing, I think we have to change that in the dialogue. I think otherwise we'll make no progress. We'll have constant short-term pressing political priorities, wholly justified, right? Like, those things are emotive because they're real. We all want nurses to be paid more. We all want the railway workers, well, I think, to be paid better, and so on and so forth. It's slightly more controversial, but you know what I mean. The broad point is sound. Fully justifiable, but coming at long-term cost. And I think
How
that
do
has
they
to change.
share in the growth? I think there's also that part as well, which is if everybody's wanting to tell a very exciting growth story, a sustainable growth story about emerging technologies, if it's only benefiting a small group of people, that's where you get the disconnect with the rest of society and the trust breakdown. So how do we do that bit?
Mind if I come in? So let me make two hopefully quick points. And so I think one of the first things I met yesterday, I won't name him because I think the company's still in stealth mode, but looking at how you completely revolutionize education, redesigning the business model and the process, right? Individually tailored, AI machine learning led programs that bootstrap your education in the way that Kumon Maths does, for those that have ever tried it. So you rapidly develop skills in a way that current education doesn't. That means interdisciplinary teams applying cutting education. But the reality of that is enabling the through life learning that we have talked about needing, but never really delivered in the UK. So it should mean that you democratize access to world-class education for everybody, so that they can learn fast enough to begin to be involved in this kind of technological revolution. So I think that training is a key element of how you address it. The second thing I wanted to say is there's a really good example from Barcelona, and I'm probably stealing your sandwiches this time, Jason. A platform called Decidim, which is a collective intelligence platform, which, as they roll out digital twins to manage local services, you get to essentially vote as an individual, constant democracy on every single thing. Like, should we enable a digital twin of your waste collection in order to improve the service that you get and reduce the cost of the council? On the other hand, doing that will mean we have your data and we will know like how much rubbish you put out when you're at home, when you're not. Well, there are loads of things we can do. Should we do that or not? And everybody votes and they say yes or no. I think empowering citizens to make that kind of much more direct democratic decisions over a whole raft of things, some of which Jason touched on in his presentation, is one of the ways that you build trust. So education and involvement.
Thank you both. I'd like to ask Ilana and Jason, both of you are talking about technologies that I think not everyone, obviously in this room, would know about, but again, the wider public, if we're looking at building a revolution, right? And I don't know if it's an industrial revolution, it's more of a thinking revolution. How would you be explaining to people, digital twins are going to make your life better? Quantum computing is going to make your life better. I'm not sure most people would even be able to explain how quantum computing works, much less how it's going to affect their lives. So if you had to paint that picture for them briefly, how would you do it?
I'd start by saying I don't think anybody needs to know how a quantum computer works. I think we are a bit self-indulgent when we feel that people should understand how a qubit works. Like, realistically, how many people really know how the smartphones in their pockets work, and about, you know, the microfabrication process of their individual bits? Like, no one cares. But what they do care about is what we can do for them on an individual basis, and making sure that we can tie the applications and the impact to the technology and its nascency today is super, super important. So again, starting to think about, you know, actually, for me, the fact that we don't understand the world around us, Mother Nature, the individual molecules and atoms, like, that's just fundamental. And you can really tie that to an individual's, you know, meaning, an individual's purpose, to help them understand the why behind the technology and why behind the importance. And, you know, everybody has got a family member, unfortunately, that has likely suffered from some sort of disease that we would like to make sure is solved, but we can't currently do that. It's too expensive, or we don't understand the drugs behind them. So even the fact we don't understand water, we don't understand solubility effectively, which is hugely limiting. So making sure that we can create these case studies, showcase that potential on a human level, and then tie that to the impact of at an individual level that the technology can provide. I don't care whether my grandma actually does know about qubits now, but and so does her friend at church. But but come on, like, she doesn't need to. I just want her to know that we're doing something that's life changing. We're doing it from a place of love and ethical consideration, and that this has the potential to change the world.
I think there is a really key thing in there around actually who needs to know what at a given point in time. And this isn't about sort of being patronizing about the role of technology. I think it's that people have a limited span of caring about things, and they care about things that are very immediate and local to them. When it comes to digital twins, I mean, one of the issues why you should care about it is if you look at all the advantages you've already got because of the way that we've used modeling and digital information to inform decision making to improve things for us. If you drive a car around the city, if you drive a modern car, if you drive anywhere through traffic lights, you're looking at a situation that works because there is a digital model behind it. Air travel, everyone's got gets a weather forecast, and you can see how that's evolved. Weather forecast, lovely example. Years ago, you watched the telly and somebody stuck a little sort of plastic cloud somewhere near where your town was, and you knew that tomorrow it might be overcast. And now you pull your phone out and you've got a real-time radar picture with a prediction for the next 2 hours about where the cloud's going to go. So you can decide to hang on for 2 minutes until it's passed and you know it'll be clear because you can see the clear sky behind it. That's phenomenal, and it's natural because it solves the problem for me, which is I don't want to get rained on. I don't necessarily want to think of that as a digital twin with sort of information integration and underlying architecture and everything else. It's a solution that fits in my pocket and it works really well. And we're finding that again and again. Clients don't want digital twins. Clients want problems solved. We know that this is the right answer to solve that problem, and we want to have them on the journey with us as we develop the technology and we start to integrate them. But they need a problem solved, and it's us. It's our job as integrators to reach out and make that connection between the art of the possible and the pain point. And then I think, if I can just list the pain points that I think will be solved in the next 5 years that can't be solved now because of these, that's the pitch.
Well, I guess that would be my question. We've got a few minutes left before we need to wrap up. Let's end on a hopeful note. It's very easy to do doom in tech, so maybe we could, for once, do optimism. What are you most hopeful about the kind of problem that you think we could be solving based on your respective expertise in your area? And perhaps, Keith, if you wanted to take the more general national view.
Okay.
We're looking at you.
Yeah. So look, let me come back. Like, if there's one thing that I think we should be tackling, is that need for longer term thinking in order to inform current policy making. So overcoming the short termism that has caused that gap to create. And I think technology can both help you imagine and test alternative futures and begin to show you how you might go about tackling those things and what the benefits might be of doing so. So changing the national dialogue about technology with technology.
Excellent. Thank you. Ilana.
I'm most excited about being able to create a new type of battery enabled by an OQC system. That's my goal, personally, by 2040.
What would you be able to do with that new battery?
Oh, power the world so much more effectively, so much more efficiently. Isn't that amazing? I can also talk about fertilizer, but it's there's a word associated with that I'm probably not going to say on camera. But again, like thinking about energy solutions, we can help make a more sustainable world by identifying these specific problems. And right now, I think like 14% of the world's energy is used creating fertilizer, which requires high pressure, high temperature environments, but Mother Nature does photosynthesis around us every single day, and we don't understand it. But if we can understand this one tiny molecule and how that evolves on a mathematical level with a quantum computer, you could then completely revolutionize how we feed the world around us and save a ton of energy doing it. So there's these specific points. If you can just understand that one tiny energy band gap more effectively, or that one tiny molecule more effectively, the impact can be profound, and it really will impact the whole world.
Brilliant. Thank you.
Small dreams.
Yeah.
You know.
Yeah.
I want to see what happens when you
What are you
make
gonna
big, if that's all.
Well,
Great.
I was about to start thinking about chlorophyll and Rubisco, but no. Well, I think from the perspective of digital twin story, I think the exciting thing on the cusp thing I'd like to see is digital engagement. I think more people across a wider part of society being more able to join in their social life with the people around them, because they share the same information, they have the same understanding, they have the same ability to discuss it. And I think opening information to people and giving them the ability to be part of that conversation, because we've democratized access to data through people being part of it, I think that is potentially revolutionary. I think it opens up the door to what Keith talked about with that productivity gap, and through to sort of being a stakeholder in society again. And then taking advantage of some of these phenomenal technologies, which will be opened up by applying quantum computers to the problems we can't currently solve. Yeah, the future's bright.
I'm afraid I'm going to have to end this part of asking questions and answers, but to reassure you, we can ask questions and answers with a beverage or food over in the other room. I just want to give our speakers a bit of a break, because I know everybody's voice is probably a bit strained, and also a chance for you to come and interact and chat amongst yourselves, because you've been so patient. So thank you very much for your time this evening, and we look forward to talking with you in the next room over there.